Now that we've practiced a new way to graph for a different situation, if we are given the equations like normal, then we'll graph it the way that I showed you before, with a table. You can come up with your own ways to do this faster, but in order to get faster, you have to practice the basics. It's like you can't dribble between your legs before you even practice dribbling regularly. This is you practicing your dribble regularly. That's a basketball reference in case you don't play any sports. Let's do the parent function. We talked about it yesterday, but we never graphed it. The slope. Is there any number there? Is there any number here? You don't see it, but we'll find that number out just by counting. How many x's is that? That is 1x. That's 1x. Since that is 1x, the coefficient is 1. If it was a 2 there, then that would be 2x's. Since there's nothing there, if you just look at the variable, that is one single x. And what's this number? What's adding to it? Plus what number? Well, there's nothing adding, so that means a plus 0. Since there's nothing adding, we have a plus 0, which means the y-intercept is 0. Now let's make a table for this. X, y, 0, 1, 2. Y is equal to x. If I put 0 into that formula, then my y will be 0. If I put 1 into that formula, then my y will be 1. If I put 2 for x, then y is also 2. In this parent function, anything that you pick for x, if you pick 1 for x, you're going to have to find 1 for y, and that's where your point is going to be at. 2 for x means 2 for y. 3 for x, 3 for y. The parent function goes plus 1 for every 1 that you go over. Then we just connect these with a line. Something else about the parent function that you'll notice eventually is, well, all of these axes are at right angles from one another. That's a right angle, that's a right angle, down here is a right angle. All of the axes are 90 degrees away from the next one over. If this line is cutting directly in between, halfway in between the y-axis and the x-axis, that means that this line, y equals x, is at a 45-degree angle. I don't know if you talked about degrees last year, but this is going to show up, if you do pass this class, this is going to show up in geometry next year. You're going to be all about angles, and y equals x is a 45-degree angle. Now let's just do y equals 2x. In the equation, we have y equals mx plus b. That's the formula. So for the letter m, we have 2. Do I have plus anything? It's a plus 0, so b is 0. Now let's make a table for that. The reason why we're labeling these things is because, as dumb as it is, there's going to be a question at some point that just asks you, look at this equation and tell me the slope. Or it's going to say, look at the equation and give us the y-intercept. And if you don't ever practice that, you're going to be that person who misses the easiest question on the test. And I don't want that. But now let's graph number 3. Y is equal to 2x. We get to pick the x's, so I pick 0, 1, and 2. We're going to do 2 times 0, 2 times 1, 2 times 2. For the first answer we get 0, 2 times 1 is 2, and 2 times 2 is 4. So our first 3 points are 0, 0, 1, 2, and 2, 4. Sorry I skipped that part on the first example, but here it is now. 0, 0, 1, 2, 2, 4. Connect them with the line. Done. Since this is our first one with a fraction, I'll go ahead and do it even though it's no big deal. M is 1/3, B is 1. Let's make a table. 0, 1, 2, and this time I'll put 3 because y is equal to 1/3 x plus 1. If I put 0, that's 1/3 times 0 plus 1, which is 1. Then it's 1/3 times 1 plus 1. That's 1/3 plus 1, which is 1 and 1/3. 1/3 times 2 plus 1, that's going to make 2/3 plus 1, which is equal to 1 and 2/3. Finally, 1/3 times 3 plus 1 is equal to 3/3 plus 1, which is 1 plus 1, which is 2. So, fractions aren't a big deal, and you need to be comfortable with multiplying them. The only way you become comfortable is by doing it and not using a calculator. If you use a calculator, you're never going to be good with fractions because you're always going to be using a calculator. So just continue to do these the old-fashioned way, and you'll be fine, I promise. Our coordinates are 0, 1, 1, 1 and 1/3, 2, 1 and 2/3, and 3 for x, and 2 for y. Let's graph these. 0, 1, 1, 1 and 1/3, 2, 2 and 1/3, 2 is with 1 and 2/3, and 3 is with 2. I would recommend that on your graphing paper you also use the scale as ones. You could separate your scale, but I wouldn't recommend it yet. Like, you could expand these numbers and make them farther away on the x-axis, but don't do that, because then you wouldn't be able to see this. You wouldn't be able to see that whenever we have a slope of 1/3, if you changed your scale, you wouldn't see that this line is closer to being flat than this last one, and even the first one. If we compare, like, let's see if I can copy paste this. Copy, paste. I copied and pasted the exact line for y equals x, the parent function, and I put it on here. Oh, let me move it down. So now we can directly see that the pink line is not as steep as y equals x. Y equals x is more steep. And the reason is this slope. And slope is called slope because it measures how steep lines are. I don't know if I've talked about that this year. We've talked about the rate of change and how that means something is going to grow in real life, or maybe you're earning money per hour, so the higher you're earning per hour would mean the steeper, the more slope you would have. But if you graphed that, somebody who's making a ton of money, their line wouldn't look like this one either. Their line could look something like that. It would be an extremely steep line if you graphed it on the same axis. So the slope is going to change how steep your line is. This pink line The slope is 1/3, so it's not very steep. It's kind of a, if you were walking on this line, it would be a gentle slope. But this 2x, y equals 2x, look at that line. If you're stepping up that, that's like, you would want some stairs. You wouldn't want to climb that with no stairs. That's almost going straight up a wall. And unless you're Jackie Chan, you're not going up walls. Now you do this last one, and then I'll show you the answer in about 5 seconds. There is the line for the last example. The y-intercept is at -4, and then it should go up by 2 every one space you go over.